This is a chemistry tutorial on analytical chemistry. First things first, this may seem a very small, easy chapter to do, and it is, but by no means should you just put it aside for the last minute or anything, because trust me, it does carry a lot of weightage. Often in section B, where you have 10-mark questions, I remember in some of our papers as well, there were whole 10-mark questions devoted entirely to the topic, and they were just, fill in the blanks. There is a lot of learning up to do in this, but it is worth it. It's straight 10 marks if you do it well. So I'll be looking to help you over here. Uh, your syllabus in this chapter is divided into two. There's detection of gases. The first part is gases, and the second one, which I think is more important, is ions. It's more important, I think, because gases you would have come across many times before, properties of some common gases. Ions, I don't think you would have done it before. So anyway, I'm just gonna start off with gases first. The neutral gases, acidic gases, and basic gases. In your syllabus, there are not too many, but the neutral gases are the usual neutral neutral gases in your syllabus would be O2, H2. I think H2O is also in your syllabus. I think that's about it. A bulk of your gases in your syllabus are acidic, and I hope you know what acidic, neutral, basic means by now. There's a whole chapter devoted to that, acids, bases, and salts. So you can refer to that if you want to know more. Acidic gases, there is the usual CO2, there is H2S, other sulfur ones are SO2, uh, and there's I think 2 or 3 ones involving nitrogen as well. There's NO2, uh, there is Cl2, there's also HCl gas, and there's also HNO3, and I think that's about it. Uh, yeah, that's it. Okay, and basic is basically only one gas, that is NH3, which is ammonia. Now, just going over the basics again. Uh, Acidic gas, it means that when you take a blue litmus, say you take any one of these gases and you have blue litmus paper over here, what this gas will do is, through a chemical reaction which you don't need to know right now, this color of this blue, it changes it, it forms a new compound and changes it to a red. So this becomes a red. It's a property of all acids. Okay. Now, basic gases, NH3 is the only one here. They do the exact opposite. You give them red litmus here, and soon, due to a chemical reaction, what'll happen is that it'll start to turn blue. So that's one of the ways to distinguish between an acidic gas, and a basic gas. Um, and neutral, you can guess neutral have no effect. So if you give them blue, nothing happens, it'll remain blue. If you give them a red, it will remain red. So they have no effect on litmus paper. Um, Now, some of the other properties that you'll be coming across, one of the major ones is, of course, color. Color of the gas, it often eliminates all the other gases because the colors are often very, very unique. For example, Cl2 is greenish yellow, so that you can identify straight away. O2 is colorless, hydrogen is also colorless, carbon dioxide is also colorless, sulfur dioxide is also colorless, water vapor is colorless, hydrogen chloride is colorless, and there are a couple of more. So if it's colorless, you're going to have a bit of a trouble because uh, it doesn't really tell you much. Now the second major thing is just does it have any effect on any other compounds? For example, to identify HCl, you can call this chemical property. Okay, chemical property. I'll give you a simpler example right now. You've probably heard of this before, that carbon dioxide turns lime water milky. Uh, that's a reaction which I'll come to later. Sulfur dioxide does that as well. Those are the only two in your syllabus that do that. Um, Also, to say identify hydrogen chloride, when you have an NH4OH solution, you could name this NH4. I don't have space, but you know what I mean. NH4OH solution, and say you have HCl gas in a container over here. You take a rod or a stick or whatever, I think you should call it a rod. You take this, it's been dipped in NH4OH, and take this towards the HCl. This is HCl. The reaction that takes place, I'll come to that when we study HCl, but the reaction that takes place, it produces dense white fumes. So that's a way to recognize these two gases. Sorry, only HCl, not NH4OH. Another example of chemical property would be sulfur dioxide. It turns pink, KMNO4, potassium permanganate, that is, it turns it colorless. So from pink, this is potassium permanganate, KMNO4. If you bring sulfur dioxide near it, there'll be a chemical reaction taking place, of course, and it'll turn into a colorless liquid, something like water. And I know water is not grey, but you know. Okay, fine. This is for chemical properties, and there's also odor. Uh, Again, this is not very useful here because most of your gases are odorless. There are 2-3 which have a sort of choking or irritating odor, as they call it, but that doesn't really tell you too much. You can't distinguish between them, it's not really unique. There's one exception: sulfur dioxide is unique that it smells of burnt sulfur. Also, the other sulfide gas, hydrogen sulfide, it's very unique because it smells of rotten eggs, so you can make out that pretty quickly. Other than that, there's not really any other property that can help you. There's also, under chemical properties, you could add indicators. You have certain indicators. Litmus is the major one. which we already discussed. There's Ki paper, which is potassium iodide paper. I should write that down. Ki paper. We'll do that when you come to NO2. And I think that's it. There's also starch iodide paper. We'll do that under chlorine. And that's it, I think. Um, that's for gases. Now I'm just going to do each of them very very quickly, and just a little tip, you could call it. While I was doing this chapter, uh, not only should you make tables, but you should also try and associate certain compounds with certain colors in that table. You'll be doing that over time once you do the other chapters as well. For example, when someone says chlorine, there should be greenish yellow all over your mind. Someone says NO2, brown should be on your mind. It should work like that, and you don't need to learn those. It'll come to you as you go by your syllabus. So uh, that of course helps while learning and going through this chapter. So this is a chapter that you'll do well in as long as you do the others well as well. Okay. Um, Now, first I'm gonna start off with the typical colorless ones. I'm gonna make my brush smaller. Okay, the first one you're gonna study in detail is oxygen. So of course O2. I'm gonna go through the major properties. It is colorless. I'm just gonna draw little diagrams with colors, with the appropriate colors in under each of the gases, so you could use this as a sort of visual aid while doing this chapter. Colorless, and throughout this, sorry, but I'm going to denote colorless by this grayish color, because I can't not use a color and make it colorless. So it's colorless, it's odorless. I'm just going to make a dash over here under odor. This is color, odor, and chemical properties. Um, the only one you could call a property is, we could say, neutral to litmus. So I'm gonna just depict that. That should be enough. Similarly for the red litmus as well. And what else? It relights a glowing splinter. That's very very important. Uh, when you have uh, a glowing splinter, let me. How should I show this? Um, just gonna take. Say there's a splinter over here, glowing. If you introduce oxygen gas into this little flask, what will happen is that this will relight. Not a very nice way to depict it, but I think you understood. And anyway, you should just learn this as a property. This is the only one that relights a glowing splinter. And also, this shows that oxygen is a supporter of combustion. That's a very important property. So that's all really you need to know about oxygen. Uh, Usually you'd be given this property. This is the one that separates it from the rest. So you need to know this. I'm just going to change color here. Um, okay, your next one is hydrogen. Uh, Hydrogen, at least I associate it with a sort of bluish color, and I'll just come to that as well. H2, that's a large arrow. That's better. Okay, color, odorless again. So odorless, colorless. Sorry, not odorless. It's colorless. It's also odorless. it is also neutral to litmus, same as oxygen so far, but the difference comes here. Now, when the property goes something like this: a glowing splinter burns with a blue flame and produces a pop sound. Um, if you have a glowing splinter, I'm gonna draw one, even though it looks pretty horrible. If you have a glowing splinter and uh, you get the H2 gas onto it, around it really, what'll happen is that it'll start burning, but not with the normal yellowish flame, but with a big blue flame. And this is the reason why I think I associate H2 with this light aqueous blue. You should remember this. And pop sound, so I really don't know how to depict it via this um, pop, I guess. You get the point. Okay, that's all there is for hydrogen. Now, water vapor is your next one. H2O. Oops. Okay, H2O. No changes in the first two columns. It is also unfortunately colorless. It is odorless. No neutral to litmus. So again, blue litmus turns to blue. Also, just note that here I'm drawing blue litmus, but the same is true for red litmus as well. It will have no color change with these gases, that is. Okay. Now for water vapor, you need to know that it is basically the gaseous form of water. So it has the properties of water really. So if I don't know if you would have done this at the time of watching this video, but you I think you may have, when you have copper sulfate, CuSO4, and you add water to it. What happens is that there's no reaction taking place, uh, but this water is not any water that combines chemically, but it just combines physically. So you can imagine that if this is a guy named copper sulfate and water comes right here, he's basically like hanging on to him, you could say. This is H2O, and okay, I'm gonna do this again. So when you have CuSO4 and you add water to it, what actually happens is there's no chemical reaction taking place between these two, but what happens is that they combine physically, and the water is then called water of crystallization. You would have done this in acids, bases, salts maybe, and it's represented like this: CuSO4.H2O. It's actually .5H2O. So for every CuSO4 molecule, you'll have 5 H2O molecules hanging onto it. Also, notice that this H2O can very easily be taken out of this compound. All you have to do is dry it and it'll be out. And you should know that this H2O is the reason why you see CuSO4 as a sort of bluish color rather than a white color. I'm just going to write that because that's very, very important. It's so usually CuSO4 on its own without this H2O is just like white powder, but with that H2O along with it, it turns into bluish crystals. and the water is, as I said, called water of crystallization. This is a change that comes across, and this is one way to identify water vapor rather. That if you condense this gas, if you condense it and hence convert it to a liquid, so the vapor, if you convert this vapor to liquid, and keep in mind this is water vapor over here, and this of course is an H2O, and you add this liquid to white copper sulfate, it will turn blue. So this is one of the ways to identify water vapor. Also, there's something called cobalt chloride paper. Cobalt is COCl2. This is COCl2. Okay, this is also called cobalt chloride, and there's cobalt chloride paper actually, and when it's brought in contact with this H2O, that is, it turns from blue, it turns from originally it's blue, and it turns into a shade of pink. So these are two ways to identify H2O. Basically, first liquefy it, convert it into water, convert the water vapor into water, and then test the properties of water. Just to sum it up, turns cobalt chloride paper from blue to pink, and just remember it's not the other way around. Many people think that because water is always associated with turning things blue, as it is in this case. It turns CuSO4 into from white over here to a bluish over here, and you should also know the water of crystallization over here. um, I think that's it for this tutorial. I've gone way over time. I've exceeded 20 minutes now, I think. So in the next tutorial, I'll be telling you about the other gases.